Good day. We are completing our examples of ice calculations. So this will be our third more complicated question. In fact, this one will be quite complicated. And so just follow along and hopefully it makes sense. So we're given all this wonderful information. We're given a reaction. They're all gases. And we're given a KQ value. And that's all we're given. And that means, since it tells us nothing about equilibrium, we're going to have to use some algebra. We're going to have to use x as a variable. Let's see how we get on. So we're going to write this equation. We're going to keep this number in mind when we write out the KQ expression, and we're going to plug in these 0.2 zeros in our ice chart. So there we are. We write out the equilibrium. We spread it nice apart, so it's easy to have room. Ice, and we're told what we have initially. Now, since we're not told what we have, at the end, we got to remember there's a 1, and a 2. And the coefficients matter. They're the stoic, and they matter at this level, the level of changes. On the left side, we're going to get minuses. On the right side, we're going to get plus. Minus x, so minus x plus 2x, because we have a coefficient of 2. Now we're ready to just do the subtractions and this addition. So at equilibrium, we end up with this. So just a bit of accounting here. We got 0.200 minus x, 0.200 minus x, and we had a 0 there plus 2x, so we have a 2x there. We're going to take these and we're going to plug them into our KQ expression. So here's the KQ. And now we're going to plug them in. Now you might think, oh, we're going to multiply out, expand, and come up with a beautiful quadratic equation. But when we have a perfect square like this, well, there's a little shortcut we can take. And that is we can square root both sides. So that's what we're going to do. We're going to take the square root of 55.6, keep it there. And we're going to take the square root of this over this, 2x over 0.200 minus x. So we'll get our square root there. Now we're not going to get a quadratic. We're going to get an expression and solve for x. So we're going to bring this up across the equal sign. So all we've done is rearrange. That's moved up here. Now we're going to expand it out. So boom minus boom is 1.49. Minus 7.46 equals 2x. Now we're going to gather the x's. So we get 9.46x equals our 1.49. And now we're going to divide both sides by 9.46. So x equals 0.158. Then we just have to go back to the original question and see what it wanted. Well, it wants the concentration of HI, which we know at equilibrium is 2x. And so the HI is 0.316 big M. So that's one of the more complicated kind of questions, and what you're going to see your challenge in the math of equilibrium is figuring out what kind of question it is. And that takes practice. All right, hopefully that made sense.